Okay, now we are going to figure out what the reaction is at R1 and R2 if we have a point load. So a point load is a specified point specifically at a certain location within the beam and concentrated at one point. So to do this, we are going to go back to what we learned with moments from about a month or so ago. And what we are going to do is we are going to treat R1 and R2 as moment points, and we are going to determine how these loads are working along those specific moments. So to start with, I'm going to determine how the moments are acting around point R1, which is right here. So we have this moment here of the point load, which is at 1,000 pounds to 10 feet over. And I've got my reaction on the other side, which is 20 feet from R1, and I do not know what that load is. So to start with, we're going to start with our first moment. So technically, my R1, there's a moment there too, that's 0. And I'm just going to draw this in the first line and leave it at that. So R1 times 0 is 0, because there's an unknown force, but it's also at 0. So our first moment is the point load. So that is 10,000 pounds, and that's going in a negative direction because it's going clockwise, and it's 10 feet over. So that's minus 1,000 times 10. And then my other moment now is at point R2, which is 20 feet away, but I don't know what that force is yet. So I'm just going to get rid of that R1 times 0, which gives me this equation. I'll multiply the 1,000 times 10, that's 10,000. I'm going to, since that's a negative, I'm going to add 10,000 to both sides, which ends up being R2 times 20 equals 10,000. I'm going to divide my 10,000 by 20, and I come up with my R2 of 500 pounds. So there's my R2, it's 500 pounds. Okay, so now we're going to solve it for the other side. We are going to make R2 our point where we're figuring our moment, or the point of our moment from right there. And we're going to clean up this elevation here. So again, there's a moment right at point R2 that's going up, but that's that distance is 0 from that moment point, so that ends up being 0. So we have our red force is the 1,000 times 10, except now that's in a positive direction because it's going counterclockwise. And then we have minus 20 times R1, and that's in a negative direction because that's going clockwise around R2. I'm going to just clear up that R2 times 0, and I'll multiply the 1,000 times 10. So I come up to 10,000 minus R1 times 20 equals 0. I'm going to basically subtract R1 times 20 on each side, which ends up being R1 times 20 equals 10,000. And divide that by 20, R1 equals 500. So I have my R1 is 500 pounds, my R2 is 500 pounds. And that is because this weight is exactly centered on that beam.